Okay, so today I'm going to do Chapter 13, number 10. Philips Inc. produces two distinct products, A and B. The products do not compete with each other in the marketplace. That is, neither cost, price, nor demand for one product will impact the demand for the other. Philips analysts have collected data on the effects of advertising on profits. These data suggest that although higher advertising correlates with higher profits, the marginal increase in profits diminishes at higher advertising levels, particularly for product B. Analysts have estimated the following functions. The annual profit for product A is 1.2712 times the ln of x sub A plus 17.414. For B, it's going to be B equals 0.3970 ln of x sub B plus 16.109, where XA and XB are the advertising amount allocated to products A and B respectively in thousands of dollars. Profit is in millions of dollars, and ln is the natural logarithm function. The advertising budget is $500,000, and management has dictated that at least $50,000 must be allocated to each of the two products. Hint: to compute natural log for the value x in Excel, use the formula equals ln x. For a solver to find an answer, you also need to start with decision variable values greater than 0 in this problem. And so A, we're supposed to build an optimization model that will describe how Philips should allocate its marketing budget to maximize the profit. And B, solve the model you construct in part A using Excel as solver. So first of all, we want to figure out what we're going to do. We're going to maximize. And what are we going to maximize? Well, we're going to add these two basically profits together. So we're going to take the 1.2712 times ln of x sub A plus 17.414 and add to that the second one, 0.3970 ln of x sub B plus 16.109, and that's what we're going to look at maximizing. And such that the x sub A, again, remember x sub A and x sub B are the advertising amounts allocated to A and B, are added together less than or equal to $500,000. That's their budget. And the x sub A and x sub B both have to be greater than or equal to $50,000. So we need to build a model with that. So again, this is what we're doing. The budget we know in hundreds of thousands of dollars is $500,000. The minimum allocation is $50,000. And so what we want to do is we want to find these product A and product B, their advertising budget. Okay, and so our total here between the two, B8 plus B9 is going to be there. And what we want to do is we want to find the profit. Well, profit, that's just our equations here. So we just have to type those equations here, and then we just take the two and add them together. And so what we need to do is we need to use solver. And basically what we're going to do is we want to set the objective, which is going to be our profit here, the total profit. We want to maximize that, and we want to do it by changing these two variables, the advertising for A and B. And what we have to do is we have to set B10, which is the total has to be less than or equal to the 500,000, and these two both have to be greater than or equal to 50,000. So that's all the constraints we have to worry about. And so if we go ahead and go to data and solver, and I've set this up so everything should look like this, then we go solve, and yes, I want to do that. And now what we find is we're going to have to do $381,000 of advertising for product A and $119,000 in advertising for product B, and that will get us a total of, which is our actual budget, and our profit in millions of dollars is product A is going to get 24.969 and product B will be 18.006 for a total profit of $42.975 million. Okay, so that's how we're going to do question 10 when they're asking for building our optimization model using these two equations with the natural log and then solving it in Excel. Hopefully that will help you with similar problems as number 10.